All right, so in order to determine the R or S stereo configuration, in order to specify the designation correctly, we have to start by prioritizing the groups, and the lowest priority group must be facing away from us. Now, that doesn't mean that you have to redraw the molecule. It just means you have to make some decisions. So let's take a look at the first molecule. Remember, we're going to specify priorities based on masses of the atoms connected. And so sometimes we'll have a tie, sometimes we won't. We'll have to break those ties when we get to them. But hydrogen is the lightest atom, so that's going to be priority number 4, the lowest priority. Now let's take a look at the structure on the right. It's carbon versus chlorine versus bromine. There's no ties to deal with there. We know that bromine is the heaviest, chlorine is the next heaviest, carbon is the next heaviest. And so I went backwards, right? Bromine is the heaviest, chlorine is the next heaviest, carbon is the next heaviest after that. And so we've got our priorities specified. Now, is that low priority group pointed away from us? It's not. So we're looking on the wrong side of the atom, of the molecule. Now you can redraw it if you want. You could, one way to redraw a molecule without changing its chirality is to swap the position of two groups. Anytime you swap the position of two groups twice, anytime you swap the position of two groups and you just do that one time, like for instance, if I were to swap the bromine with the hydrogen, I'd actually be drawing the enantiomer. But if I do that again, then I drew the enantiomer of the enantiomer, and the enantiomer of the enantiomer is the original molecule. But I think there's an easier way to do that. And that's that just realize that you're looking at the molecule from the wrong side. So whatever designation that you come up with will be the opposite of what it actually is. And so that's what we're going to do. We're going to say it's 1, 2, 3. This would be a clockwise designation. So we would say, look, a clockwise designation relates to an R configuration, but we're looking at it from the wrong side. So we'll say, okay, I've got the opposite configuration from what it actually is. So it actually is S. So that's an easy way to do that. And then you don't have to redraw it. Okay, so let's do this next one. We did identify 4. And so it's carbon versus fluorine. Clearly, fluorine is heavier than carbon. And so now we do have a tie, right? So this carbon and this carbon are tied. So what we need to do is we need to make a list of the things that those two carbons are attached to. So let me change the colors so we have that color coordinated. All right, so what's this blue carbon connected to? What is the blue carbon connected to? It's connected to 2 hydrogens and a carbon. Now, of course, that carbon that it's connected to is a CH3 group. That carbon itself is connected to 3 hydrogens. Maybe one day you'd have to look further down the line. I don't think this is the case in this one. What about the red carbon? Well, the red carbon is certainly attached to a hydrogen, but it's also connected to 2 carbons. And so certainly these are tied and certainly these are tied, but carbon beats the hydrogen. So the red carbon is the higher priority group. So now we've got our priorities. Again, the low priority group is facing towards us. You could redraw it by switching the position of 2 groups and then doing that again so that you get the enantiomer, then the enantiomer of the enantiomer, which is the original structure. Or we can just say, look, I would get 1, 2, 3. That's counterclockwise. And counterclockwise is associated with the S position, but we're looking at it from the wrong side. So it's really the opposite of what the configuration actually is. And so the configuration is actually R. Okay.